Okay, so this one is section 10.6, and it is called, the title of it, according to the author, is Segment Relationships in Circles. So listen carefully, because today you got to switch gears. Yesterday's was angle relationships. We're talking, everything that we answered and talked about and did yesterday was all about degree measures and how we got them for certain things. Angles and arcs and how they were related, right? Everything was measured in degrees. Today, everything's going to be measured in things like centimeters or feet. We're talking about lengths of segments that are created when they interact with a circle. Same segments. Two secants, a secant and a tangent, or two tangents. So we're going to talk about the interactions and the relationships in the lengths of segments when we get those to cross. So here we go, starting out very much like yesterday, but this time we are not at all interested in how big the angles and the arcs are. We're not interested in that at all. So we get two secants to cross inside. What happens is, I mean, these have got arrowheads on them, and we don't really care what happens when they get outside the circle. It's what's inside. So if the length of this segment right here, so I'm going to call that A, and the length of this one is B, and the length of this one is C, and the length of this one is D. Just like yesterday, the way you handle this will be determined by where the cross point is, whether it's inside or outside. There won't be any cross points on the circle today. It's either going to be crossing inside or crossing outside. Two secants can cross inside, and when they do, they create four segments, and they're all different lengths, and this is the relationship. What you do, and you do this with every problem we're going to do today, if you could just adopt this method of doing it, it will be really easy. And if you can't, or you can't see it, it's going to be tough for you. So this is what I say, and this is the self-talk you do inside your mind. You say, from the cross point to the edge of a circle, that is A, times that same cross point to the other side on that same secant, D, got to multiply them, that will equal from the cross point to one edge of the circle, C, times the cross point to the other edge of the circle, B.
Do they have to be on the same line?
Yes, if they're on the same side of the equation. So if you say from here to here times from here to here, you're on one secant at that moment. Equals, then your equal sign, and then you go from cross point to the edge is C, cross point to the edge is B. When you multiply those two together, these two products will be the same. Yes?
Do they have to be in a certain order?
No. But these two on this side have to come from one secant, and the two on this side have to come from the other secant. And no, it doesn't matter the order. But I would recommend you adopt this notion because it will serve you in all the rest of the stuff I'm about to demonstrate. If you go from the place where they cross, wherever that is, go to the edge of the circle and write it down. Then start at the cross point again. Stay on the same line. Go to the other edge of the circle and write it down. Equals. And do the same thing with the other one. And this is what I mean. We could get two secants to cross on the circle. That won't provide us with four segments. So I'm only going to do two secants crossing outside the circle. Now this is where this method that I'm trying to drill into you so far is really going to come home, see if you really understand what's going on. If I get two secants which cross outside the circle, like that, and they don't have to cut off equal chords or nothing, I still have four segments that were made by that crossing. I have an A here, and a B here, C here, and a D here. I'm just arbitrarily putting those on there. Now watch, and do it the way I taught you to do over here, the very same way. We go from cross point to edge of the circle times cross point to the other edge of the circle. Did you catch that? It's not B and A. It's B times B plus A. Because the distance from the cross point to the other edge of the circle when it's out here is B plus A all the way to that back end. So it is the segment from the cross point till you hit the circle. Write it down. Then stay on that same line. Cross point to other edge of the circle. That's A plus B or B plus A, whatever. Right? Okay, so you got to keep that in mind. And that will equal C times C plus D. Follow that? And we did the very same thing over here. It's just that when we went to this edge, we had to go to the other edge. We went the opposite direction. In this case, we're both going in the same direction. Where we go to front edge, back edge, multiply them. Front edge, back edge, multiply them, and they will be equal to each other. Again, I'm going to do some examples for you in a minute, but I want to get the thoughts out here. And in both cases, it's cross point to circle times cross point to other edge. Cross point to the front edge, cross point to the back edge, which requires us to add some things. Okay, now, can you get a secant and a tangent to cross inside the circle? Because that's the next thing I'm going to consider is a secant tangent combination. Can you get those to cross inside the circle? Can we get them to cross outside the circle? All right, here's a secant. Here's a tangent. Pretend that's snugged up against there. Now I've only got 3 segments. Still, if you can follow me with the scheme of this, it'll still work. I've got an A and a B and a C. Here's the cross point. So I'm going to go from the cross point to the front edge of the circle and write it down. Whether it's a variable or a number, write it down. Then I'm going to stay on that same secant, that same line, and I'm going to go from the cross point to the back edge of the circle, just like we did over there, and it is B plus A. Equals. Still holds true here. If I go from the cross point to the first hit, that's C. And if I go from the cross point to the second hit is also C, I get C times C. So B times B plus A equals C times C. It's just that this one showed up twice, as front edge and back edge happen to be the same thing. We're going to use it twice. Every case, cross point to edge, write it down. Cross point to other edge on the same line, write it down. Or cross point to edge, cross point to edge. And it's just kind of weird in this case that we go that to the front edge and then come back there and do it again to the back edge happens to be the same number. Can you get 2 secants to cross outside, or 2 tangents to cross outside the circle? Because let me show you that I've considered every possibility that I wanted to consider today. 2 secants cross inside. If they cross on the circle, we don't have anything because we haven't got 4 segments. Here we've got 4 segments if 2 secants cross outside. So I've got inside, not considering on, outside. Then I did a secant tangent combination. This is the only one we can get to cross outside. And then we got 2 tangents. Can you get 2 tangents to cross inside?
No.
Can you get 2 tangents to cross outside?
Yes.
If you do that, it looks like this and like this. And there's only 2 segments, but we already have a theorem for it. Remember? So this one was discussed earlier. These are the only new things here. So let me show you. I'm going to erase this one because we already know this is true. From the cross point to here and the cross point to here, we already know that relationship. They're equal. So these are the only 3 new ones. Now let's do a couple of examples and see if we can figure out which one to use and how to do it. So look at example 1. We've got one that looks like this. One of those things appears to me to be almost, it doesn't tell us it is, but most of diameter. I would say it's not quite. We got that one. And the other one's coming down at kind of an angle like this. And they tell us these items on here. We've got x plus 2, x plus 4 for the big ones. This one's x plus 2, x plus 4. And the other 2 are, oh, this one's just x. Oh, there's another one. X plus 1 is this little dude right here. Good grief. I got them all smashed in there. I think that's what we've got. Is that right?
Yeah.
Okay. So cross point to edge. I'm going to go this way first. X times cross point to other side on the same line, which is x plus 4. That's why I have parentheses. Equals cross point to edge. And it wouldn't matter which order you did it in. You could put the x plus 1 first if you wanted to. Cross point to edge, x plus 1. You see that follows this scheme here?
Yeah.
It's kind of ugly, kind of a lot more ugly than this because they've got binomials on those secant objects. But that is how you put this together based on the geometry that I just taught you over there. And the geometry is over, like it usually is. Now we got to depend on your algebra skills. So we distribute the x, and that gives me x times x is x squared plus 4x. Over here, I got to FOIL this out. It's going to be x squared plus x plus 2x plus 2. Anybody not follow that from your memories of algebra? Anybody? Now we clean things up. I can't combine these because you can't combine x squares with x's, but I can combine these 2 right here. That's going to give me x squared plus 3x plus 2. That's as cleaned up as that gets. And here's the happy thing that's going to happen to you right here. As we try to get everything together on one side, the x squares will add right out. If I subtract x squared from this side to try to get it over here, I've got to subtract it from this one, and they're just gone. Nice. People usually don't like to deal with quadratics, well, it's been eliminated. So now what I have is 4x equals 3x plus 2. I take the 3x from the 4x, and I get x equals 2. Now, what did they want us to find? They want us to find the length of ML and JK. ML is this whole length here. That whole length right there is going to be 4 plus 3. Y'all see that? Plugging the 2 in and doing the arithmetic?
Yeah.
And is the JK the other long one?
Yes.
Okay, so it'll be 2 plus 6. Okay? Follow all that? The geometry ended as soon as you wrote this. Now you got to depend on what you learned in algebra. So if you did really poorly in algebra, this might be pretty tough for you to get the right answers. I don't know. Okay, so there's one example of the first one. Okay. Take a look at example 2. I'm going to just take my book with me to the board and write down the equation to go with it. You look at the picture and see if you can understand why I wrote what I wrote. Want me to draw the picture and show you why that is? Anybody? For those of you watching this on if you don't have a book in front of you, it's going to be hard to tell why I wrote that. So let me put the picture with it, and you see if you can figure out why we wrote what we did. So the picture looks like this. I've got a secant coming out to there, and another secant coming from this point down to there. This is x. This is 10. This is 9. And this is 11. And we are just looking for the value of x. This right here is this situation right here, which means I need to take this and go to the front edge and write it down. Yeah. Then I go back here, stay on the same line, and I go the back edge and realize that's 20 because 9 and 11 is 20. Write it down. You see that? That's that one plus that one all the way to the other edge. Equals. Now I go on the other line. From this point to the front edge of the circle is 10. Write it down. From this point to the other back circle on the same line is going to be 10 plus x. That's why I wrote that down. Does that make any sense?
Yeah. Mm-hmm.
Now, in order to dodge the picture as I come around, usually I let the equal signs follow pretty closely down, wrap right around this is 180, because that's what 9 times 20 is, equals, and I'm going to distribute the 10 through there, which will be 100 plus 10x. Okay? 180 minus 100 is 80. 80 divided by 10 is 8. But you've got to be able to put it together right. It crosses on the outside. You're going that times that equals that times that. Okay? That's how you use that one. Okay? Let's look at example 3. And it says, we've got another, I'm going to erase this one, I'm going to put another picture in. I'll draw this one also. I guess we don't need this anymore either. Okay, so I'm going to write something down about this. You look around on what I gave you and see if you understand why I wrote what I did. It's going to be x times x plus 8 equals 16 squared. Yeah? Y'all see it? Everything's good. Okay, so now we do the algebra. It's going to be x squared plus 8x equals 256. Since it's quadratic, and since the x squares did not add out this time, the way we handle quadratics is to bring everything over on one side, preferably the side where the squared term is positive. So I'm bringing the 256 over, and I get this. And again, I'm coming down around here. X squared plus 8x minus 256 equals 0. And now we've got two options. We can either factor it if it will, or we can use the quadratic formula on it,
Why didn't you just divide by 8?
because I can't divide this by 8. I mean, this doesn't have an 8 in it. Yeah, okay. So do you want to try factoring, or do you want to jump to the quadratic formula? Tell me how you want to go about handling this. Because it's tough to factor something. Even if this is a 1, it's tough to factor something that has 256 in the back. Because most people don't know their factors of 256.
Is the
Do you want to try to factor it? I think we could, but or do you want to just jump to the quadratic formula? The quadratic formula will give you the answers, whether it's factorable or not. But you got to remember the formula. Do you remember the formula?
No.
Then let me erase some of these over here so I can show you. I'll leave that one up there because that's the one we're using. That's this one right here. But let me remind you, the quadratic formula says this. If you have a quadratic of this form, ax squared plus bx plus c equals 0. In other words, you set it all up so that you've got the squared term first, the single term, the linear term second, and the constant last, which is what we do over there. I'll apply it in just a minute. Quadratic formula says that the value of x right here will equal negative b plus or minus the square root of b squared minus 4ac all over 2a. Where a is the number in front of x, b is the number in front of x squared, b is the number in front of x, and c is the constant, along with their signs. Do you recall this from algebra? I hope. At least, maybe you don't recall the details, but you remember using something like this?
Yeah.
Better get this committed to memory if you intend to use it. So to apply it to this, we would say x equals negative b. This is a positive 8. And so I will write down negative 8. But if this had been a negative 8, I would have written down positive 8. Whatever this is right here, its opposite goes here. That's what negative b means. Doesn't mean a negative number. It means the opposite of b. Yeah? You with me?
Yep.
Plus or minus the square root of. And the next thing we do is square that number. Now, it doesn't matter whether this number is positive or negative, because when you square it, it'll always be positive. Always. This number is never negative. Minus 4 parentheses. This is how I teach my kids. Just put the minus 4 parentheses and deal with the signs up here. Don't try to deal with that at the same time. Because it's minus 4 AC. So I need to take 1, which is understood to be right there, times negative 256. Over twice A is 2. Yes.
I thought you said it would never be negative.
What?
I thought you said it would never be negative. The 64.
It won't be. That 64 is not negative.
Oh.
This could be negative. It's not. You'll see in just a minute. It's not negative because order of operations says get inside that radical. It's kind of like a grouping symbol. And simplify this first. And when you get inside here, you do multiplication, which is these guys before you add that 64 to it. So it's going to be a negative 4 times a negative 256, which is 24, 1024.
1024, yes.
Plus 64 is 1088.
Yep.
So it's negative 8 plus or minus the square root of 1088 over 2. 1088 a perfect square? I don't recognize it. I don't think it is. Nope, it's pretty ugly. Let's see how they want us to answer this. They have it in radical form. They also have it as a decimal. So I'll continue to show you, and none of this is geometry. I'll continue to show you how we would simplify this to put it in radical form. You remember that if I had, for example, the square, well, I put it over here. Do you remember if I had something like the square root of 108? I taught you to take 108 and prime factor it.
Yeah.
Does that look familiar at all?
Yeah.
We got to do that to 1088. So I'm going to grab my calculator. 1088 is even, so I know at least 2 will go into it. That's all I know for sure. So I'm going to try to prime factor it over here. I'll do it over here. It belongs to this problem. 1088, I need to prime factor to see if I can find the pairs. So I know that 2 will go into it 544 times. I know that 2 will go into this because it's even. And it goes in 272 times. And that's even. So I divide it by 2 and I get 2 and 136. That's even. So I divide by 2 and I get 68. That's 2 and 68. 68 is even. That's 2 and 34. 34 is even. That's 2 and 17. And 17 is prime. So here's a pair of 2s, here's a pair of 2s, and here's a pair of 2s. One of each pair gets to come out and multiply. So I get 2 times 2 times 2 is 8. Root 17. You see that? Okay. Now, if I divide that thing by 2, if there's a 2, as I got 3 terms here, this one, this one, and that one, and they all have a 2 in them. So if I cancel a 2 out of everything, I get -4 plus or minus 4, root 17. Do you agree with that?
Yeah.
Now, -4 minus something else is going to be negative. That has to be positive because it's a length. So I can ignore that part. So -4 plus 4 root 17 is the length of this segment. As a decimal, that is, and we go -4 plus 4 square roots of 17, close it, is 12.49. So this is approximately equal to 12.49 if you want to represent it as a decimal instead of a simplest radical form. Here's the way I will treat it on a test. If you had something like this and you had to use the quadratic formula because it wouldn't factor, you don't know how it was going to factor. By the way, it won't factor because this came out irrational. It doesn't factor. We could have worked all day on that to get it to factor, but never would have worked. So going the quadratic was a good choice. If you can give me this answer, you'll get full credit. If you can give me this answer, you get extra credit. Yes.
Sorry, really quick. How did you get to 12.49? I got lost with it.
-4. So in your calculator, type -4.
Okay.
-4 plus 4. Then find your square root button because it knows to multiply. So go square root of 17. Close the parenthesis or whatever it takes. I don't know, mine doesn't do that. And then hit enter.
Oh, okay.
Now, we got that because we simplified all this down. We're able to just put that in the calculator. You're going, well, I could get to there and then give you the decimal. I already have that. No, you could have taken it from right here. Right at that point right there when you simplified, you could figure out that you get 12.49 from there. This one's a little tougher to plug in. You go -8 plus the square root of 1088, enter, and then divided by 2. That'll give it to you as well. That way you can get from the simplified quadratic without having to simplify this radical, you can get the decimal form of this without having to do this. This is the extra credit part. Do y'all follow what I'm saying? Okay. If you did -8 minus that, you would soon discover that you have a negative, which you can ignore because this is a length. They have to be positive. Okay, so there's no need to do the subtraction one. You could, but you get a negative number, and then you look at that and go, oh, yeah. So that was crazy, huh? Yeah.
I don't know what the add or subtract on the calculate the quadratic formula.
How do you know what to add or subtract?
Yeah.
Because if I took -8 minus something more, it would get more negative, and this has to be a positive since it's a length. You see? Now, if this minus this was actually a positive number, you'd have to give me 2 answers. One with a minus and one with a plus. But this minus one on this particular problem won't make any sense. Because x is a length from the picture that we see. Crazy, huh? Yeah, you're going to have to remember your quadratic formula in some cases today. So you might want to either take a picture of this or make sure you've written it down. Because this is how it applies. And then you got to remember how to simplify it. Once you get this, all this crap written down, it is a lot of stuff. Make sure you remember to multiply these two together before you combine it with this. Okay, one more example. Finding the radius of a circle. All right. Last example says this. Find the radius of the aquarium tank. I don't know what's swimming in there. What do you think is swimming in there?
Fish.
Look like tadpoles or something. They got big eyes sticking out. Anyway, we're not interested in what's swimming there. I was for a second, but anyway, this is the circle that we've got. We're supposed to find the radius of this tank. And we've got an 8-foot and a 20-foot. Comes out like this. We got 8. Oh, that was supposed to hit the circle. Pretend that it did. Okay. This is the information they give us, that we got an 8 and a 20 here. And we are supposed to find this. So what I'm gonna do is find this and cut it in half. Because that's what applies to this situation right here. So I go from cross point to the front edge of the circle. Multiply times the cross point to the back edge, which I'm going to call 8 plus x, equals 20 times 20. Okay? When I find x, I won't have answered the question. What the author wants you to do is write this, which you could. It'd be perfectly fine. Maybe we should. I don't know. You can write that as 2r. Because this piece right here is 2 radiuses. Right? Do you want to do it this way instead so we can get it directly?
Sure.
Okay. But that whole length, when you do 8 times the whole distance across there, if you're looking for r, that whole other thing you got to add is actually 2 r's. So if I do that, I replace that with 2r instead of x. Do the r one will be 64 plus 16r equals 400. Subtract the 64 to get at that r. It's going to be 400 divided by minus 64 is 336. Then you got to divide it by 16. Right? Is that 21?
Yeah.
Okay, so the radius of the tank is 21. If I had done it with an x here, we would have gotten 42, and I would have had to cut it in half. Doesn't matter how you have it. But the information that they gave us requires us to use this idea right here, which is front, all, then use that one twice. You can have it? Very short assignment, 3 through 17 odd. That's it, 3 through 17 odd. That's all you gotta do.
There we go.